A surge of blue light. Then nothing. A brief pulse hidden behind the sun, recorded only in the final moments before the sky concealed everything. And you traveller arrive at a story shaped not by certainty, but by the quiet edges of observation. What if an object older than our own star brightened in ways no comet should? What if the silence behind the sun was not absence but transformation? Instruments caught only fragments, temperatures that made no sense, a glow that deepened instead of fading, a whisper from an earlier universe passing through ours. Stay a while, let's drift through the quiet together. During the final approach to the sun, the object unfolded a transition so quiet that even the instruments designed to measure brightness seemed hesitant to interpret it at first. It did not warm in the soft linear way comets usually respond to sunlight. Instead, its luminosity rose in a curve steep enough to escape comparison, increasing with a power law far beyond what the physics of sublimation could justify. There was no eruption, no violent burst, just a steady accelerating bloom of light, expanding as if responding to something deeper than heat alone. In moments like these, astronomy becomes less a study of motion and more a meditation on the unexpected. The data revealed a relationship impossible to ignore, the brightness scaled with distance to the power of 7.5. That number carried weight. It meant the object was not merely reflecting more sunlight as it drew nearer, it was amplifying its own glow in a manner that seemed almost sculpted. Natural comets from the outer cloud sometimes exhibit dramatic flares, but those comets are rich in volatiles. This one, however, carried only 4% water, far too little to justify the behaviour. Yet, there it was, brightening hour by hour as though awakening after a long pause. Silence sometimes speaks through numbers more clearly than through words. Stereo A confirmed these changes from two instruments running in parallel. The heliospheric imager displayed a growing envelope of light, while the coronagraph traced the same expansion with startling clarity. The halo stretched outward nearly 300,000 kilometers of scale, typically reserved for far younger, more active bodies. The sheer size of this structure invited questions not of classification but of history. What processes sculpted such a halo around something so old? What quiet engines of chemistry persisted in the object's interior, still capable of releasing dust and gas in patterns that mimicked the grandeur of earlier cosmic epochs, as other observatories joined in the pattern repeated? Each one documented the same blooming structure, not chaotic, not jagged, but layered. GOES 19, with its compact coronagraph, revealed subtle gradations, ridges, and faint arcs that gave the halo a delicate order. These were not the turbulent waves expected from random jetting. They resembled something patient unfolding at a pace too slow for real-time comprehension but too deliberate to ignore. In astronomy, order appearing where randomness should dominate often becomes the first whisper of a new mystery. Soon, attention turned not to structure but to colour. When the spectral data arrived, it carried a surprise no model had predicted. The emission skewed bluer than the sun in visible wavelengths. A comet whose surface should be hundreds of degrees colder than the photosphere should not emit light at such temperatures. Reflection could not explain it. Thermal radiation could not explain it. Even fluorescence fell short. The numbers suggested that a portion of the light was generated internally from processes unable to find a home in known comet behaviour. Light sometimes reveals not what an object is, but what our understanding is not. Researchers debated possibilities with calm curiosity. Perhaps rare molecules fluoresced with unusual efficiency. Perhaps surface minerals absorbed ultraviolet radiation and re-emitted at shorter wavelengths. But fluorescence glows faintly, not with the intensity recorded. Others proposed that microscopic ice structures might scatter light in ways not accounted for in current atmospheric models. Yet the object had been exposed to cosmic rays for billions of years. Its surface should be dark-weathered desaturated. Each hypothesis resolved one question, only to open another, suggesting that the truth lay somewhere just outside familiar physics. Even the disappearance of the sunward jet deepened the mystery. For weeks, the object released material directly toward the sun, a behaviour contradicting the fundamental rule that cometary tails always point away from stellar radiation. Then, near October, the jet vanished, replaced by a conventional tail pointing outward as expected. Such a shift could result from rotation, or from the exhaustion of material in specific vents, but the timing aligned too precisely with the Mars encounter, and with the passage behind the Sun. Astronomy often teaches that coincidences deserve attention, not immediate dismissal. As the object emerged from behind the solar glare, its brightness normalized, its tail behaved predictably, and most of its earlier strangeness receded into data logs and archived sensor readings. Yet the impression remained not of something alarming, but of something ancient revealing only fragments of its truth. This is often how cosmic discoveries unfold, not with revelation but with questions layered quietly over time. Multiple independent measurements confirmed that the object maintained its predicted trajectory. No deviation occurred, no sudden change in velocity, no impulse at perihelion. It moved in accordance with gravity alone, a reminder that even anomalies sometimes rest within the framework of known laws. Stability does not erase mystery, it simply frames it against a backdrop of cosmic patience. The characteristics recorded the exponential brightening, the vast halo, the blue radiance the sun would jet. The abrupt normalization did not form a contradiction. They formed a portrait of an interstellar relic behaving in ways both familiar and foreign, shaped by eras long gone responding to the sun with echoes of environments no longer present. In moments like these, the work of science becomes a long breath, a willingness to step back and allow the unknown to remain unknown. And as the object travelled onward, leaving the sun behind, the first phase of the story came to a quiet close, not with answers, but with awareness. In astronomy, that is often the true beginning. As the object drifted outward from perihelion, the brightness that once surged so dramatically softened into a more measured decline. The observatories tracking it sensed this transition almost intuitively. The tension of rapid change quieted, replaced by a steadier rhythm of data arriving with predictable calm. What had been a period defined by acceleration now became a phase shaped by reflection, both in the scientific sense and the emotional one. With each passing day, the luminous imprint left by its earlier behaviour faded just enough to encourage a different kind of attention, one that favoured detail over spectacle. Instruments across multiple wavelengths began revealing a portrait that was no longer about transformation but about endurance. Ultraviolet sensors detected faint but consistent carbon-based emissions, whispering of deeper layers that still responded to solar heat. Infrared imagers traced residual warmth along shallow fractures across the surface, evidence of stresses accumulated during the encounter with the sun's intense radiation. These features told a quieter story than the dramatic rise in brightness before perihelion, but a no less meaningful one. Objects shaped across billions of years respond to new environments with a patience that mirrors the cosmos itself. Meanwhile, visible light observations showed the halo, thinning its earlier complexity, dissolving into more subtle gradients. The arcs of dust that had once expanded rapidly now stretched gently into space, forming soft curves that drifted under the influence of solar wind. These arcs carried the memory of earlier activity, each grain, a particle released from an ancient structure now illuminated briefly before continuing its wander through the heliosphere. The fading halo became less a symbol of diminishing activity, and more a reminder that even brief cosmic events leave lingering traces. Spectroscopy continued to offer insights, though the signals now required longer exposures to capture. The nickel emission that puzzled researchers for months declined steadily, but its persistence even at low levels suggested that its source was not merely superficial. Instead, it hinted at deeper processes, perhaps a slow diffusion from interior layers, shaped under conditions no longer present in the galaxy. The decreasing intensity did not diminish its significance. Rather, it highlighted how even faint data can anchor theories about materials forged during earlier stellar generations. Polarimetric measurements added their own gentle complexity. The extreme negative polarization recorded near perihelion gave way to more moderate values, though still unusual compared to typical cometary dust. This shift suggested an evolving dust distribution, as the object moved away from the sun, yet retained enough strangeness to remind astronomers that interstellar visitors may not adhere to the patterns familiar from local objects. dust grains shaped in distant systems influenced by unfamiliar forces and aged under different radiation environments naturally bring with them signatures that fall outside expectations. The object's rotation, still subtle and difficult to measure, gradually revealed hints of periodic modulation. Brightness curves began showing slight asymmetries small enough to require careful statistical treatment, but real enough to suggest a slow, stable motion. This rotational evidence, faint though it was, enriched the broader sense that the object carried a kind of quiet coherence, not chaotic, not tumbling, simply moving with a steadiness that matched its age. Across the global network of observatories, collaboration deepened. Teams shared observations not with urgency, but with a kind of quiet reverence. The fading object required patience, long exposures, and careful refinement, and in that shared effort, astronomers found themselves participating in a collective meditation. They were no longer chasing anomalies. They were tracing a departure, watching a relic of deep time return to the dim regions from which it had emerged. Amateur astronomers contributed as well, though their telescopes could no longer capture the object with clarity. Their early images became valuable benchmarks, helping to map the brightness decline with surprising accuracy. For many, the object had become more than a scientific curiosity. It had become a reminder of how briefly such visitors remain within reach, and how much meaning can arise from the simple act of looking upward during the right moment. These experiences formed their own quiet layer within the scientific narrative, with activity diminishing, the object's behavior aligned more closely with expected thermal models. Its surface cooled predictably. Sublimation decreased. The dust production rate fell in line with established equations describing heat loss in small bodies. Yet even within this return to normalcy, the earlier mysteries lingered like echoes, proof that the cosmos does not always reveal its mechanisms cleanly. Some features would remain unexplained, and that was part of the beauty. Astronomy is not a field designed for closure. It is a field built on ever-expanding questions. As the distance between the object and the sun increased, the data streams gradually thinned. But even in their diminishing frequency, they maintained a sense of continuity. Each new observation, no matter how faint, contributed to a broader tapestry, a record of how an interstellar traveller responded to the presence of another star. The trajectory remained stable. The object moved precisely as predicted, and yet its earlier behaviour ensured that it would not be forgotten. This second phase of its story concluded not with revelation, but with quiet acceptance. Its unusual characteristics, brightening curves, emission anomalies, the sudden disappearance of the sunward jet remained intact in the minds of those who studied it. The object would continue outward, carrying its secrets with it, unconcerned with the questions left behind, and the observers in turn would remain watchful, not because answers were promised, but because the act of watching is itself a form of understanding. As the object continued its slow departure from the inner regions of the solar system, astronomers found themselves revisiting the earliest data sets, not out of doubt, but out of a desire to understand the journey with greater clarity. Those first recordings of rapid brightening, those spectral fingerprints, and those scattered traces of metallic vapour all seemed to shift meaning when placed beside the quieter behaviour now unfolding. The contrast between past intensity and present calm revealed something essential. The universe often communicates through phases, each one casting new light on the others. The persistent nickel plume offered one example of this layered communication. Early measurements showed it escaping at a constant rate, a stream too steady to be explained by surface activity alone. Now, with emissions fading, scientists could examine the long arc accumulation of data, revealing a profile more nuanced than any single moment suggested. The plume did not diminish abruptly. It tapered like the embers of a long burning fire, losing brightness but retaining form. This slow fade implied pockets of material buried beneath the surface, perhaps remnants of mineral structures forged under extreme conditions billions of years ago. Across multiple observatories, teams compiled estimates of total nickel loss. Over the months the object was active. The mass calculated was small in proportion to the full body, but immense when viewed as free metal in vapour form. Such release required internal fractures or deposits that did not align with typical comet composition. These calculations strengthened the idea that the object might not fit neatly into established categories. Yet instead of forcing it into a box, the scientific community allowed the anomaly to remain open, letting the data act as a gentle guide rather than a demand for definition. Rotation offered its own mystery. Light curves revealed only faint hints of periodicity, suggesting a slow, stable turn without abrupt changes. Perhaps the object rotated along a long axis with minimal variation in its reflective surfaces. Perhaps it spun with a subtle wobble too soft to detect. Whatever the explanation, the motion emphasized resilience. Bodies shaped by interstellar drift often find equilibrium not through symmetry, but through endurance. Polarimetric studies explored another layer of subtlety. The extreme negative polarization documented earlier had puzzled researchers worldwide, pointing to dust particles unlike those commonly found near Earth's sun. As the object moved away, those values softened but did not fully return to expected norms. This persistent deviation suggested that the dust grains themselves had histories etched by different stars, different radiation environments or pressures no longer present in the modern galaxy. Each grain carried a memory far older than any epoch on Earth, drifting through space as both artifact and evidence. The tail, once dynamic and expressive, evolved into a structure defined more by solar wind than internal processes. Its behavior became a record of the object's changing relationship with sunlight, a slow story told in curvature and faintness. Researchers built models mapping the dispersion of dust released during perihelion tracing arcs that revealed not only the timing of the emissions, but also the subtle forces shaping the grain's trajectories. In these delicate patterns, astronomers found a visual representation of time itself stretched thin and drifting freely. Radio silence continued to dominate the narrative. Arrays across continents scanned frequencies high and low, hoping for any structured signal that might offer new information about the object's interior. The absence of detection was not disappointing. It was instructive. It reminded researchers that the cosmos often expresses itself in the stillness. A lack of signal can be as meaningful as a burst. Silence described the object's behavior with its own quiet precision. Deep inside the thermal models, scientists explored how ancient structures might react to heat, absorbed during the solar encounter. These models suggested a slow propagation of warmth into the interior, followed by an equally slow release as the object cooled. This thermal inertia hinted at density or cohesion, inconsistent with the loose aggregates often found in younger comets. Instead, it pointed toward a body shaped by pressures or collisions in the distant past, perhaps even fragments of ancient planetary systems disrupted by violent gravitational encounters. Amateur observations, though no longer able to capture new details, still contributed to the study. Their early images documented the object's path across the pre-dawn sky, forming a visual timeline that complemented professional records. For many observers, the fading of the object brought a sense of closure, not loss, but completion. They had participated in something rare, witnessing a visitor from beyond the sun's domain, tracing a faint glow that carried history older than Earth itself. The object's trajectory, stable and predictable, reinforced the sense that its earlier anomalies did not signify disruption but complexity. Its motion remained faithful to gravitational models, reflecting no hidden thrust or deviation. This stability grounded the broader narrative, demonstrating that unusual behavior does not always imply ongoing irregularity. Sometimes, a single phase of strangeness is enough to reshape understanding without redefining an object's identity. Scientists reviewing the entirety of the dataset recognized that the real revelation was not a single anomaly, but the cumulative effect of many subtle irregularities. The rapid brightening, the layered halo, the blue emission, the metallic plume, the sunward jet. None of these alone forced a conclusion, but together they formed a portrait of something shaped by environments difficult to reconstruct. This was not a comet that fit neatly into models. It was a reminder that interstellar space holds materials and histories far stranger and older than those familiar to the solar system. As this phase concluded, the object continued outward with calm inevitability. The glow dimmed, the dust dispersed, the signals grew thin, but the impressions left behind remained vivid. Astronomy thrives not only on clarity, but on curiosity, not on answers, but on the willingness to dwell with the unknown. The story did not resolve here, it widened. The object offered no closure, only the quiet assurance that learning sometimes begins where certainty ends. As the object moved deeper into cooler space, a calmer rhythm settled across observatories tracking its path. The intense glow that once challenged instruments had softened into manageable brightness, allowing researchers to study structures that earlier phases obscured. What remained was not the spectacle of rapid change, but the quiet persistence of celestial behaviour unfolding at a natural pace. This new phase shifted attention away from anomaly and toward continuity. The universe, after all, often reveals meaning through what endures after the moment of intensity has passed. Infrared instruments documented the slow decline of thermal signatures across the surface. Heat absorbed during perihelion dispersed, gently revealing gradients that formed as the object transitioned back into cold equilibrium. These gradients trace subtle fractures that were not visible in earlier images, small fault lines that behaved like geographic features on a miniature ancient world. Their shapes suggested internal stresses that built over long distances, travelled through deep space stresses, released only when confronted with the sudden warmth of a nearby star. Ultraviolet observations uncovered residual traces of carbon dioxide still drifting outward. Though diminished, these emissions formed a faint veil across sections of the coma, behaving like the last wisps of vapour rising from a cooling surface. Their slow dispersal helped refine models of sublimation under extreme age and low water content. They also hinted at how different stellar environments might imprint their own chemistry on interstellar bodies, leaving signatures detectable even millions of years after formation. The visible halo, once expansive and layered, transformed into delicate arcs, almost transparent against the solar wind. These remaining structures carried information not in brilliance, but in subtle curvature. By studying the spacing and density of these arcs, astronomers traced the timing of dust release, reconstructing the rhythms of the object's earlier activity. Each arc was a timestamp, a record of interaction between heat rotation and surface composition. Even as the halo thinned, its structure continued to teach. Polarimetry offered insights into the evolving dust environment. Earlier observations had revealed extreme negative polarization, an anomaly that suggested dust unlike any commonly encountered. Now those values moderated but retained enough deviation to indicate that the grains drifting outward still carried the imprint of unfamiliar chemistry or shape. This persistence reinforced a growing understanding. Interstellar objects arrive with their own histories shaped by environments that no longer exist, scattering light in ways that reflect eras predating the solar system itself. Spectral data shifted toward reflection rather than emission. With activity diminishing, the object's true surface began to reveal itself through the colour and quality of sunlight bouncing from it. The surface appeared darker than initial models predicted, its reflectivity dulled by radiation exposure accumulated across countless stellar neighbourhoods. This darkness was not emptiness, it was memory. Radiation can sculpt surfaces over eons, roughening grains, altering minerals, transforming what was once bright into something ancient and subdued. Rotational analysis grew clearer as the dust dispersal slowed. Subtle fluctuations in brightness allowed researchers to narrow the range of possible rotational periods. The motion remained gentle, stable, and without abrupt variation. This steadiness suggested internal cohesion not commonly found in most comets, especially those from volatile-rich reservoirs. Objects travelling between stars often endure collisions, heating cycles, and radiation flows that fracture weaker bodies, yet this one retained structure. Its calm rotation became a quiet testament to resilience earned across vast and unforgiving distances. Radio listening continued in parallel. Arrays monitored the object across broad frequency ranges, noting nothing unusual, nothing structured. This silence became a focal point of its own. Rather than diminishing curiosity, it deepened respect for the neutrality of cosmic processes. Most celestial bodies do not announce their presence. They move without signal, without intent, shaped only by gravity, chemistry, and time. In this phase, the object offered an example of how silence itself becomes data affirming natural behaviour rather than hinting at complexity. Ground-based observatories adapted their methods as brightness declined. Long-duration exposures replaced rapid imaging, creating stacked composites that revealed faint structures still lingering near the nucleus. These images resembled soft sketches rather than the vivid captures of earlier months. The transformation reminded observers that celestial stories rarely unfold at a single intensity. They ripple, soften, and evolve. What seems diminished is often simply entering a different chapter. Amateur astronomers, though now unable to capture new details, revisited their earlier observations with renewed appreciation. Their images, taken from rooftops, rural fields, suburban balconies, formed a collective portrait of a moment when an interstellar visitor passed close enough for humanity to notice. These images carried emotional weight not because of scientific precision, but because they symbolize participation in something older and larger than any single observer. The night sky had offered a rare gift, and many quietly acknowledged it. Professional teams, meanwhile, prepared for the final useful data sets. Instruments calibrated for faint detection continued tracking the object as long as possible, gathering the last fragments of information before distance rendered it beyond reach. These final measurements emphasized not what the object was doing, but what it had done. With each passing day, the datasets became chapters in a story that would soon shift from observation to interpretation. As this stage drew to a close, researchers recognized that understanding does not always arise from anomalies alone. Sometimes clarity emerges from the slow return to normalcy, from watching how an object settles back into cosmic quiet after a moment of brilliance. The object's behavior, once confusing now, appeared cohesive when viewed across the full arc of its journey. It warmed, brightened, shifted, cooled, and dispersed patterns familiar in structure, even if unusual in detail. The fourth phase of its passage ended with a feeling not of finality, but of alignment. The object moved forward along its path, carrying its age and history into more distant regions of space, and those who watched it found themselves carrying something as well: an expanded sense of scale, a softened understanding of mystery, and a renewed awareness that the cosmos shares its stories in whispers, not declarations. As the object moved farther from the sun, attention gradually shifted toward the inner structure that had endured the intense conditions of perihelion without visible fracturing. Observatories studying its composition noted that the body remained remarkably intact, preserving its form even after exposure to heat, and gravitational forces capable of disrupting far younger, more fragile companions. This quiet persistence suggested that its origins were rooted in environments where pressures and temperatures differed significantly from those found in typical comet nurseries. Its endurance itself became a form of data, a hint of a deeper and more ancient architecture. Thermal analyses indicated that the outer layers cooled more rapidly than expected, yet the interior retained heat for longer periods, releasing it gradually in faint signatures. This asymmetry pointed toward density variations beneath the surface, as though different layers had accumulated through processes spanning vast stretches of cosmic time. These layers now cooling together invited questions about formation histories in earlier eras of the universe, when star systems behaved differently and collisions were shaped by dynamics no longer common in the present age. Meanwhile, high-resolution photometry traced slight oscillations in brightness that were not strong enough to mark rapid surface changes, but consistent enough to imply subtle outgassing, still occurring in protected pockets. These faint releases formed delicate streams invisible to the naked eye, noticed only through long exposures that captured the smallest variations in light. They were not dramatic, but they added nuanced threads to the overall tapestry of the object's behavior, revealing that even in quiet phases, ancient bodies continue to express their histories in gentle, patient ways. Spectral readings across near-infrared bands supported this subtle activity. Small increases in specific wavelengths hinted at molecules emerging from shaded areas that had avoided the most intense heat of perihelion. These molecules, now liberated, drifted outward, slowly contributing to a new thin layer of dust surrounding the nucleus. Unlike the earlier expansive halo, this one remained close, forming a soft boundary around the object. It resembled a lingering memory more than an active feature, an echo of processes recently awakened and now subsiding. As measurements accumulated, attention turned toward the question of structural integrity. The object had experienced forces that might have fractured any ordinary body, yet it held together. Gravity alone could not fully explain its resilience, nor could typical cohesive forces of ice and dust. Models recreated its solar encounter and demonstrated that an object composed primarily of loosely bound materials would likely fragment. This one did not. Such survival suggested an internal arrangement shaped by compression or consolidation, occurring under conditions not commonly observed in our solar system. For some researchers, this led to renewed interest in the possibility that the object originated from a disrupted planetary interior rather than a cometary field. A fragment from a long-vanished world could develop a strength and density that differed from small body aggregates. While this idea remained speculative, the data supported its plausibility. An ancient planetary shard drifting through interstellar space for billions of years could naturally acquire the darkened surfaces, metallic emissions, and stubborn resilience that defined the object's observed behaviour. Radiation measurements provided another layer of understanding. The surface exhibited patterns of degradation consistent with repeated exposures to cosmic rays during long intervals between star systems. These patterns also suggested periods when the object had passed near multiple different stars, each interaction contributing small but cumulative changes. Such journeys spanning eons shaped a surface that no longer resembled the bright ice of young comets. Instead, it resembled something weathered by time itself, an artifact carrying the imprints of diverse and distant stellar environments. The object's motion through space retained remarkable consistency. Even as it cooled, its trajectory remained stable, matching predictions with near-perfect precision. This consistency allowed observatories to plan long-term monitoring strategies, ensuring that every remaining moment within observable range would be used effectively. Predictability in motion offered a comforting contrast to unpredictability in composition. It demonstrated that even when nature presents puzzles, it often provides steady ground from which to study them. Ground-based telescopes, now adjusting to the object's decreasing visibility, shifted toward techniques emphasizing sensitivity over clarity. Longer exposures merged into smooth mosaics, capturing the faint glow that trailed behind the object like a dissolving thread of starlight. These mosaics became records of transition images that preserved the final stages of its inner solar system passage before distance rendered it only a memory in the archives of observation. Space-based instruments continued to gather the last meaningful spectral data. As brightness diminished, these measurements became increasingly precious. Each one offered a final glimpse into chemical compositions that might never again be observable at such proximity. Researchers approached this phase with reverence, aware that the opportunity would not return. Interstellar visitors arrive on timescales that exceed human generations. Their appearances are not events to be repeated, but brief alignments of cosmic paths. The object's gradual quieting did not lessen interest. Instead, it reshaped it. The earlier allure of anomalies gave way to a more grounded appreciation of the object's endurance and complexity. Understanding shifted from urgent curiosity to contemplative study. The question was no longer why it brightened so dramatically, but how it maintained such coherence over billions of years. The object became a reminder of the durability of matter shaped under extreme ancient conditions, matter that persists even after stars fade and galaxies evolve. As the fifth phase drew to its natural close, the object continued outward, taking with it the last warmth absorbed from the sun. Its glow softened, its emissions faded, and its dust halo drifted gently into the surrounding vacuum. Observers watching this transition found meaning not in the diminishing brightness, but in the enduring presence of something older than memory, continuing its path with quiet constancy. What remained was a calm acknowledgement. Understanding does not always come from dramatic revelations. Sometimes it arises from watching how an ancient body settles into silence after a moment of light, carrying mysteries that time will not easily release. As distance widened between the object and the sun, a quieter form of observation emerged across global instruments. The early months had been defined by brightness, jets, emissions, and questions pressing toward explanation. Now, with the object cooling and activity fading, a different rhythm took hold, one shaped not by urgency, but by patience. The calm allowed researchers to revisit earlier assumptions, interpreting anomalies with the gentler perspective that time often brings. In this softer phase, the object no longer challenged expectations, it invited reflection. Thermal readings continued to decline in a predictable curve, Yet the uniformity of this cooling revealed subtle internal contrasts. Some sections retained warmth far longer than others, creating slow gradients across the surface. These gradients indicated differences in density or composition that remained hidden during the intense illumination of perihelion. It was as though the object, now free from the overwhelming presence of solar heat, began revealing its interior in soft, cooling breaths. Each reading offered another layer of understanding, another quiet clue to its ancient construction. Spectrometers detected faint traces of gas lingering near the nucleus molecules that resisted complete dispersal, even as the surrounding coma thinned. These last emissions behaved like echoes of earlier activity, emerging not from vigorous sublimation, but from deeper pockets of material responding to thermal transitions. Such persistence suggested that the object's interior contained zones insulated by compacted minerals, areas where heat travelled slowly enough to create delayed micro-outgassing long after the primary event. Even small details like these added dimension to the broader portrait. Surface analyses strengthened the impression of an unusually cohesive body. Under normal circumstances, the abrupt shift from intense heating to rapid cooling creates fractures shedding material in predictable patterns. Yet high-resolution imaging revealed no major breakage, no flaring debris fields, no structural collapse. Instead, the surface showed an almost serene resilience, dark, weathered and steady. This stability hinted at a formation environment where pressures and temperatures forged a material far more resistant than ordinary cometary ice. Perhaps in some long-forgotten era, the object experienced conditions that shaped its internal matrix into something capable of surviving the extremes of cosmic travel. Polarimetric measurements, still unusual even at this distance, continue to support the idea of dust grains shaped by foreign histories. Values remain distinct from solar system norms, though softened by distance and declining activity. The grains drifting away from the nucleus still bore the signatures of processes unknown in contemporary stellar environments, evidence of chemical pathways or structural formations belonging to earlier cosmic periods. Observers treated these measurements with quiet respect, aware that they represented the preserved stories of stars long gone. The object's trajectory remained steady and predictable, following gravitational lines with precision. This reliability comforted observers accustomed to tracking hazardous bodies. Unlike younger comets whose volatile compositions can introduce chaotic shifts, this ancient visitor appeared anchored in its path. Its predictability became part of its character, an object shaped by eras of drift long accustomed to the silence of deep space, now passing through the solar system with neither disturbance nor deviation. Stability in this context felt almost poetic. As brightness declined further, telescopes transitioned into deeper exposures. Frames that once captured dramatic halos now revealed only a faint core surrounded by the thinnest suggestion of dust. Yet these faint images offered their own form of beauty. They illustrated a cooling memory, a fading trace of an interstellar object that had briefly intersected with the warmth of another star. This stage resembled the final moments of a long-held note, quiet, sustained, lingering with intention before dissolving into stillness. Models simulating the object's interior suggested that its unusual emissions during perihelion could arise from layered compositions developed over billions of years. Each layer might have formed under unique conditions, from early planetary collisions to interactions with passing stars. When heated unevenly, these layers could respond with surprising behaviour. Abrupt, brightening metallic vapour shifts in jet direction. Now that activity had quieted, the models gained clarity. They no longer functioned as explanations for anomalies. They became tools for imagining a long and complex origin story. Radio observatories, still listening with patience, confirmed the absence of structured signals. What remained was the soft background hum expected from natural interactions between solar wind and dust. This silence affirmed again that most cosmic bodies communicate only through motion, scattering reflection and heat. The lack of intentional signal did not diminish interest. Instead, it restored the narrative to the object's own material history. Its voice, if it had one, existed only in the physical traces it left behind, each data point a quiet syllable in a language of particles and light. Ground-based researchers reflected increasingly on the rarity of opportunities like this. Interstellar objects pass through the solar system on timescales beyond any individual career. The ability to observe one so intimately across multiple wavelengths and during such a dynamic phase felt like witnessing a page turning in a cosmic journal rarely opened. The fading brightness did not signal the end of interest, but marked a transition from active observation to deeper interpretation. The data collected now belonged to time, ready to inform new models, new theories, and new questions. Amateurs who once captured its early glow now traced its faint departure using coordinates alone. Their images, though no longer possible, remained as records of a moment where human eyes connected directly with something older than the sun. These memories, quietly preserved, became part of the object's legacy. Across continents, individuals who may never meet had shared a moment of looking upward toward the same solitary visitor. As this phase concluded, researchers recognized that the object's journey had begun to speak less about anomaly and more about endurance. It had demonstrated how ancient bodies carry both chaos and calm within them, how moments of radiance can coexist with long stretches of silence. In this sense, its story reflected a broader truth about the cosmos, that change and stillness are intertwined, each shaping the other across spans of time too vast for human reckoning. The 6th chapter closed gently, not with revelation, but with a soft return to quiet. The object continued onward, cooling into the darkness between planets, its mysteries intact. And those who observed it found themselves learning something subtle yet profound. Sometimes the most meaningful discoveries arise not from what is illuminated, but from what remains in shadow. As the object drifted steadily toward the outer boundary of the inner solar system, the nature of observation shifted once more. The early intensity of spectrographic peaks and light curve anomalies had softened into a gentler cadence, a rhythm marked not by surprises but by the steady unfolding of faint signals. The scientific community, now accustomed to the calm, approached the data with a different mindset. Curiosity remained, but it was a quiet curiosity shaped by acceptance rather than expectation. Each new reading felt like a final footnote to an extraordinary passage. Photometric measurements captured the continued decline in brightness with remarkable precision. The curve tapered smoothly, mirroring the natural cooling of a body, leaving the warmth of a nearby star. Yet within this predictable descent lay subtle irregularities, small oscillations that hinted at lingering internal processes. They were not strong enough to suggest renewed activity, but they revealed that the object had not reached complete thermal equilibrium. It was still releasing fragments of its experience, fading gently into temperatures more familiar to deep space. Infrared images revealed fading hotspots across the surface, the last remnants of heat absorbed during perihelion. These areas cooled at slightly different rates, offering insights into the diversity of materials embedded within the object's crust. Such patterns echoed the behavior of ancient bodies shaped under extreme pressures, dense regions retaining warmth, while more porous areas shed temperature quickly. This variance created a surface map that resembled quiet geological contours, a topography shaped not by landscapes but by composition alone. Dust dispersion near the nucleus slowed considerably. Earlier in the journey, grain streamed outward in broad arcs influenced by rotation and solar wind. Now the ejection rate had diminished so much that new dust barely drifted beyond the immediate vicinity. Observers noted that this reduction marked the natural conclusion of the sublimation cycle triggered by the sun. The object had expressed what it could express. Now it returned to the silence shaped by the long, cold journey through interstellar space. Spectroscopic readings captured the final traces of metallic vapor. The nickel signature, once continuous and unexpectedly strong, had nearly vanished. Only faint remnants appeared at the threshold of detection. This decline deepened the mystery surrounding its source. Whatever mechanism powered the earlier release had now grown still, leaving behind no clear explanation. The absence of emissions did not resolve the puzzle, it merely reframed it. Some mysteries researchers understood are best approached through patience rather than immediate answers. Radio observatories continued their steady listening. The silence across monitored frequencies remained consistent, producing only natural patterns associated with dust-ion interactions and solar wind scattering. With each passing day, expectations shifted gently toward closure. The lack of signals became less a point of speculation and more an affirmation of the object's passive nature. It moved without broadcasting, without intent, without interruption, an object shaped solely by physics and the ancient conditions of its origin. Ground-based telescopes adapted to the fading glow by relying increasingly on long exposure stacking techniques. The object now required extended integration times to capture even the faintest profile. These images, though dim, possessed a quiet beauty, soft outlines, traced against a dark backdrop like sketches of something too old and distant to ever be fully illuminated. Observers found themselves drawn to these quiet frames. They held the serenity of a relic departing gently from view. Rotational analysis grew clearer despite decreasing brightness. The slow, stable spin persisted without significant variation. This continuity reinforced the impression of a cohesive structure, one that carried its mass evenly and resisted the stresses of thermal shock. The rotation told a story not just of movement, but of identity. It reflected an internal order that survived encounters with stars, collisions with dust fields, and the vast emptiness between systems. Models simulating the object's past continued to evolve. Researchers explored scenarios involving ancient planetary collisions, tidal disruptions near massive stars, and chemical formation pathways in early cosmic epochs. Each model illuminated a different aspect of the observed data. None offered a definitive answer, but each contributed a thread to a narrative woven across billions of years. The uncertainty did not diminish the research, it enriched it. The object had become a reminder of how little is known about the earliest materials in the galaxy. Amateur stargazers, now unable to capture visible traces of the object, continued to follow its coordinates out of quiet dedication. For many, the experience had shifted from observation to reflection. They tracked its movement not for new discoveries, but for the simple act of acknowledging its presence, a distant point of light, crossing the cosmic stage soon to vanish beyond the reach of their instruments. In these quiet moments, astronomy became less a science and more a practice of attention. The object's gradual fading brought with it a renewed awareness of scale. It reminded observers that the brightest phases of discovery often last only briefly. A moment of clarity, a sudden outburst, an unusual emission, a fleeting structural change can shape years of interpretation. But the universe does not pause for us. Objects move on. The data grows thin, and what remains is the memory of what was seen, studied, questioned, and accepted. In this 7th chapter, the object's presence became almost ghost-like, visible only through careful effort, tangible mainly through the data it once produced. Yet its impact lingered. It had challenged assumptions, inspired collaboration, and introduced new questions about interstellar materials and their interactions with stars. Even as it faded, it continued to shape understanding. The departure did not feel abrupt. It felt natural, like the end of a long exhale. The object moved forward along its predicted course, leaving behind the last wisps of dust and the soft echo of its passage through sunlight. And those observing it understood that this quiet phase marked the beginning of its return to darkness, carrying within it the traces of its encounter with a star that had warmed countless worlds long before this moment. What remained was a gentle acknowledgement that some cosmic stories are meant to be witnessed only briefly, understood only partially, and remembered through the faint signatures they leave behind. As the object moved deeper into the widening gulf between Mars and the asteroid belt, its presence softened into a faint point of measurable light, still traceable, but no longer commanding attention in the night sky. Observatories adjusted their strategies accordingly, turning toward exposures lasting hours rather than minutes, treating each new detection as a small affirmation that the visitor still lingered within reach. In this subtle stage, the pursuit of detail became an exercise in patience, and the quiet nature of the data matched the calmness of the object itself. Photometric curves leveled into a nearly uniform decline. The brightness faded with a smooth consistency that signaled an end to active changes. No sudden surges, no minor flares, only the gentle recession of a body, cooling back toward equilibrium with the surrounding void. The predictability of this dimming allowed astronomers to extract faint rotational markers otherwise hidden in brighter phases. These markers described a slow, deliberate spin, suggesting that the interior mass remained stable and undisturbed. Infrared analysis captured the shrinking thermal imprint, patches of lingering warmth visible after perihelion now blended into the broader surface pattern. The variations flattened until only a faint gradient remained. These final readings helped refine models of thermal conduction through dense, aged material. They supported the hypothesis that the object possessed internal cohesion, uncommon in small icy bodies, pointing instead toward a hardened structure, shaped by ancient processes no longer active in the galaxy. Dust emissions, once a defining feature of the object's interaction with sunlight, dwindled into near silence. High-sensitivity coronagraphs detected only the faintest wisps drifting behind the nucleus, moving in slow waves shaped more by solar wind than by internal forces. This quiet dispersal offered a last glimpse of the material history preserved within the object. Every grain carried clues about chemistry, radiation exposure, and the environments through which the object had travelled, even if only a fraction of those details could be deciphered. Spectral signatures showed a similar fading. Traces of carbon compounds weakened into noise. Metals that once appeared clearly now hovered near the threshold of detection. What remained in the data resembled a faint shadow of earlier months, a reminder that the most compelling features often appear only in brief windows of illumination. Scientists reviewing the decreasing spectral lines found themselves reflecting on the transient nature of astronomical opportunity, that some revelations emerge only when conditions align for a short, fragile moment. The continued absence of radio anomalies reinforced the picture of a passive celestial body. Arrays scanning millions of frequencies reported only the expected scatter from dust and plasma interaction. This silence was not disappointing, it was clarifying. It demonstrated that the object expressed itself only through material presence, not through signal or design. These conclusions, though simple, helped ground interpretations that had grown speculative during the earlier period of brightening and structural complexity. As the object approached the outer regions of the inner solar system, dynamical models predicted increasingly stable motion. The gravitational contours of the heliosphere guided its path with quiet precision, carrying it outward along a trajectory that would intersect the asteroid belt at a shallow angle months later. Observers found comfort in this predictability. It affirmed once more that despite its ancient origin and unusual behaviour, the object remained firmly bound to natural principles. Ground-based telescopes transitioned almost fully to composite imaging. Individual frames no longer revealed the object, but stacked exposures, sometimes hundreds combined, produced faint dots marking its path across the starfield. These dots formed patterns that resembled beads on a nearly invisible string, each one a moment of connection between the Earth and a relic of distant worlds. For many observers, these images carried a quiet beauty. They represented not clarity but effort, the human willingness to look deeper even when the light grows faint. Space telescopes, though limited by their schedules, captured the last high-resolution views. These images provided a closing portrait of the nucleus dark, compact, and strangely smooth in its overall silhouette. No new vents appeared, no fractures expanded. The object seemed to have settled back into its primordial stillness, as though the solar encounter had awakened it briefly only to let it rest again. This reversion felt natural, even comforting. Celestial bodies often change only in moments. The rest of their time is spent enduring. Researchers reflecting on the accumulated data recognized that the puzzle was no longer about explaining anomalies. Instead, the focus shifted toward integration, combining light curves, spectra, polarimetry, radio silence, and thermal readings into a single coherent narrative. This narrative did not provide absolute answers. It offered something gentler, the sense that understanding can emerge even without resolution. Mystery remained, but mystery softened into context framed by the broader structure of interstellar evolution. Amateur observers continued tracking its coordinates even as the object grew too faint for their telescopes. For many, the body's fading became symbolic, a reminder that cosmic stories move at scales far larger than human timescales. Something that shone brightly one month could become invisible the next, yet still persevere on its long, indifferent course through space. The experience of following such a visitor remained meaningful, even when direct observation ceased. As the object moved farther away, it entered a region where sunlight weakened into a pale wash, and solar wind loosened its influence. The tail grew diffuse, dissolving into dust too fine to measure. The nucleus appeared as a dim fragment of something older than the solar neighbourhood continuing its journey, with the same quiet persistence it had always shown. Observers sensed this transition not as an ending, but as a passing. A movement from one state to another, from the realm of study to the realm of memory. This 8th chapter closed gently, marked by stillness rather than discovery. And in that stillness, observers learned again that not every moment in astronomy is defined by revelation. Some are defined by the grace of watching something ancient fade from view with the dignity of a long-enduring story. As the object continued its slow outward drift, researchers turned their attention toward the broader implications of what had been observed. The earlier months of activity had left behind a record rich with irregularities, quiet signatures and unexpected alignments. Now, with the object fading, scientists could step back and consider not just the data, but the patterns hidden within it. The shift in perspective allowed themes to emerge that were not apparent in the moment of discovery. Sometimes meaning forms only after the brightness dims. One question that lingered concerned the cumulative nature of anomalies. No single feature, neither the sunward jet nor the blue emission, nor the metallic vapour, stood alone as conclusive. But taken together, they formed a sequence that seemed too structured to dismiss. While none of these irregularities demanded extraordinary explanations, they encouraged a reconsideration of how interstellar materials behave when awakened by a star's heat. Researchers began to explore whether such objects might preserve exotic compositions shaped by early cosmic epochs, compositions that respond dramatically when warmed after millions of years in the cold. Theoretical models expanded to include conditions from the galaxy's early history. Ancient star-forming regions produced chemical pathways unfamiliar in the present era. Supernova remnants seeded space with metals in different proportions. Collisions between young planets created fragments with densities and mineral structures seldom found today. If the object originated during these formative eras, its unusual behaviour might reflect nothing more than the imprint of a universe still settling into its long-term patterns. In this sense, the anomalies became windows into ancient astrophysical environments. Polarimetric irregularities added weight to this view. Even in the object's quiet phase, scattered light revealed dust grains with shapes and compositions not easily matched to known models. These grains might have formed around stars with different radiation profiles, or within disks where pressure and density shifted rapidly. Some may have originated inside planetary interiors before being cast into space by tidal disruption. Their persistence across billions of years offered insight into how durable such fragments can be, carrying silent records of environments long erased from the galaxy. CO2 and nickel emissions, though nearly gone, continued to inspire debate. That these materials appeared at all challenged assumptions about what an interstellar traveller could retain after eons of irradiation. Theories proposed that internal caverns or mineral lattices trapped volatiles long after surface layers eroded. When heated, these pockets released their contents in subtle stages, producing emission curves that defied the symmetry typically expected from comets. The fading signatures did not solve the puzzle. They underscored its complexity. As curiosity deepened, the conversation around the object gradually shifted from uncertainty to humility. Researchers recognized that explanations, even when incomplete, held value. The lack of absolute answers did not reflect failure, it reflected the scale of the universe. Small bodies drifting between stars are shaped by forces and histories spanning billions of years, far beyond the scope of current understanding. The object served as a reminder that astronomy is as much about acknowledging limits as expanding them. Observatories continue to refine its trajectory, confirming with increasing confidence that it would exit the inner solar system along the expected path. This stability prompted discussions about how many such objects may pass unnoticed through the heliosphere each century. With detection capabilities improving, statistical models suggested that the solar system may host more interstellar visitors than previously believed most too faint or too distant to observe. The current object may not be unique. It may simply be one of the few bright enough for detailed study during a brief alignment. researchers began to frame the event within a larger cosmic pattern. 3 confirmed interstellar objects in under a decade pointed toward a galaxy rich with wandering fragments. Some would resemble icy comets. Others would reflect metallic compositions from ancient planetary cores. A few might reveal chemistries uncommon in the solar system. Each one would contribute a new perspective on the processes shaping star systems across time. In this way, the object became not an isolated case, but part of an expansive ongoing narrative. Amateur observers and professionals alike acknowledged the philosophical dimension of the encounter. The object's passage offered a rare opportunity to observe material untouched by the processes that shaped the solar system. Its anomalies reminded observers that not all cosmic stories follow familiar patterns. Some unfold quietly, revealing only fragments of their truths. Others pass through the solar system with barely a whisper, leaving questions that endure long after the object fades from sight. As the 9th chapter progressed, the object's light diminished, until only the most sensitive instruments could detect it. Data streams grew short and infrequent. Each new point of confirmation was treated with gentle respect, recognizing that even a faint detection preserved the continuity of a story, nearing its observational end. The object's presence became more symbolic than measurable, an echo preserved in calculations, logs, and shared experience. Researchers now deeply familiar with its behavior reflected on how the encounter reshaped their understanding of interstellar material, not through decisive revelation, but through a gradual accumulation of insight. The object demonstrated that cosmic mysteries do not always arrive with clarity. Sometimes they unfold slowly, dissolving into quiet realizations, each one nudging understanding forward. As the chapter drew to a close, the object continued along its outward arc, unchanged in motion but softened in presence. It carried its unanswered questions into the dim regions where sunlight fades into deep shadow. And observers watching from afar felt a calm recognition. Some stories are not solved, they are simply witnessed. As the object travelled past the orbit of Mars and approached the threshold of deeper space, the geometry between Earth's sunlight and its fading form reached a configuration ideal for final observations. Instruments calibrated for faint detection found the object drifting through a region where interference diminished and the sky softened into clearer contrast. This stage offered one last opportunity to refine models before the visitor slipped into a realm where even long exposures would struggle to hold its light. The moment felt both technical and contemplative, a quiet convergence of clarity and departure. Spectrometers documented the final shifts in composition with meticulous care. Carbon signatures continued their slow descent toward undetectable levels, while the residual traces of metals waned into the noise of background photons. These diminishing readings were expected, yet they carried a reflective quality. Each spectral line, once sharp and bright, now appeared like the fading pulse of a long story receding into silence. Analysts noted that the decline followed curves consistent with exhaustion rather than sudden cessation, reinforcing the idea that internal reservoirs had simply completed their interaction with warmth. The dust environment surrounding the nucleus dispersed even further. The earlier arcs and soft contours shaped by radiation pressure and gentle rotations dissolved into indistinct threads that the solar wind stretched thin. Models predicted that only the largest grains would continue travelling near the object, while the smaller ones drifted into trajectories shaped more by sunlight than by the object itself. This transition resembled the final pages of an illuminated manuscript, slowly losing their ink, leaving form in place but letting details fall away. Infrared imaging, once rich with gradients revealing thermal diversity, now displayed a cooled body nearly uniform in temperature. The disappearance of hotspots implied that internal heat had dissipated fully. Even the insulated pockets that lingered during earlier phases reached equilibrium with the surrounding void. This outcome strengthened hypotheses suggesting dense internal composition and high thermal inertia. Objects shaped under extreme conditions often retain heat long after incandescent events, but eventually even they surrender it back to space. As the object approached the outer edge of the inner solar system, its rotational signature grew faint but remained measurable. The stability of this rotation across months of observation astonished researchers. A body exposed to tidal forces, thermal stress, and asymmetric outgassing would typically show slight adjustments in spin. Yet this visitor preserved its motion with quiet persistence. The consistency invited speculation about internal symmetry or mass distribution uncommon in most small objects. Whatever the explanation, the behaviour suggested a history of survival one shaped by far older encounters than the brief passage near the Sun. Astronomers also reflected on the absence of fragmentation. Within the observational record, no debris trails, no sudden brightness drops, no structural failures appeared. The object remained whole, unbroken, even as temperatures swung from near frozen to significantly heated during its solar encounter. This resilience implied a natural architecture capable of withstanding extremes. Theories pointing toward origins in disrupted planetary interiors or early star-forming regions gained traction, supported not by dramatic evidence, but by the quiet logic of structural endurance. Ground-based telescopes once again adjusted their approach. With brightness nearly gone, researchers coordinated globally, using overlapping windows to extend exposure times and stack images separated by wide intervals. These mosaics revealed the faintest outline of the object crossing starfields, like a soft graphite mark drawn across a page. The beauty of these images lay not in detail, but in persistence, the human desire to continue watching, even as the light dimmed to near invisibility. Space-based instruments captured their final data sets, adding precision to trajectory calculations that would define the object's exit path. With each refined measurement, the predicted future position grew clearer. The object would pass into the outer solar system, through regions dominated by dust, small asteroids, and the long arcs of gravitational resonances. From there, it would drift outward until the Sun became just another distant point among countless others. Observers treated this knowledge with quiet acceptance. The universe does not hold on to its wanderers, it guides them onward. Discussions across research teams increasingly focused on context rather than anomaly. The object's behaviour, while unusual, could be placed within a spectrum of possibilities shaped by billions of years of cosmic evolution. It reminded astronomers that interstellar matter is diverse, not because it defies explanation, but because it reflects histories spanning far more time and space than the environments familiar to the solar system. This shift in perspective felt like a closing of one question and the opening of many more. Amateurs continued to follow the object's coordinates out of devotion rather than expectation. Though they could no longer see it, the act of aligning telescopes toward a fading visitor held symbolic meaning. It represented continuity, a way of acknowledging that something ancient had passed near Earth, offering a glimpse into eras unreachable by any other means. Observers spoke of it not as a spectacle, but as a presence, one that enriched their experience of the night sky. Scientists prepared final papers summarizing months of observation. These studies emphasized the object's layered behavior, initial anomalies, gradual normalization, and eventual return to silence. They highlighted the interplay between known physics and conditions shaped by distant worlds. They framed the encounter as both scientific and reflective, a reminder that knowledge expands not only through answers but through the willingness to dwell within uncertainty. As this 10th chapter came to a natural close, the object continued outward, growing dimmer with each passing night. Its presence persisted only in data memory, and the shared recognition that something older than the Sun had moved briefly through the warmth of our star. The story it carried was never fully revealed, but it left behind a quiet imprint, one shaped not by revelation, but by the enduring grace of a journey across time. As our journey drifts to its quiet end, traveller, let your thoughts settle, like dust in the long shadow behind the Sun. We have followed an object older than our world, watched it brighten, fade, and move beyond our reach, and in its silence it has reminded us of something simple and profound: the universe is always speaking, even when we do not yet understand its language. What happened behind the Sun did not give us certainty, it gave us perspective. A reminder that every anomaly is an invitation, every unanswered question, a doorway, every faint photon, a message carried across unimaginable time. The mystery continues alive and unhurried, unfolding in places where our telescopes cannot yet see. And through all of this, we remain small but never insignificant. We are watchers of the sky, listeners at the edge of cosmic tides, tiny minds tracing ancient light. There is humility in that, and also hope. Because as long as we continue to look upward, wonder will never leave us. So let the quiet stay with you tonight. Let the cosmos hold its shape around your breathing. Another story will find you when you're ready. Rest well, traveller. Stay curious, the universe will keep watch. As the object entered regions where sunlight thinned into a muted glow, its presence shifted from something observed to something sensed. Instruments that once traced sharp boundaries now captured only faint signatures, soft reductions in brightness, slow changes in temperature and spectral hints dissolving into the background. This stage felt less like an ending and more like a natural return. The visitor had come close, warmed briefly, revealed fragments of its long history, and now drifted back toward the deep silence from which it emerged. Trajectory models reached their final refinement. With each passing day, the object followed its gravitational path outward with unwavering precision. No irregularities appeared, no small accelerations or deviations, no hints of internal thrust. The stability reaffirmed what had become increasingly clear, whatever complexity lay in its chemistry and structure. Its motion remained governed by simple celestial mechanics. Predictability brought a quiet reassurance. It allowed researchers to shift from active tracking to reflective study, knowing the path ahead was steady and untroubled. Spectral readings continued to fade. The last remaining traces of carbon dioxide and metal vapor fell below reliable detection thresholds. What once produced lively debate now settled into soft diminishing signals. Scientists archived each measurement with care, aware that these final data points represented the last direct communication before the object moved too far for detailed study. The transition from rich spectra to near silence mirrored the larger arc of the encounter. Brightness followed by calm anomaly, followed by acceptance. Ground-based observatories captured their final exposures through prolonged integrations, producing images that resembled faint pencil marks drifting across the darkness. The object no longer displayed a halo or stream. Even the dust it carried had dispersed into the solar wind. What remained was a compact point of dim light slipping slowly toward the boundary where observational certainty ends. These images, though simple, held quiet meaning. They marked the closing of a chapter in which Earth briefly intersected the path of something ancient. Researchers began synthesizing the full story. They reflected on the rapid brightening, the unusual jet, the metallic emissions, the striking polarization, the resilience under solar heat. Each anomaly offered clues, but none formed a full explanation. Instead, together they created a portrait of a body, shaped by environments that no longer exist, an object older than the sun carrying traces of early cosmic epochs. The inability to resolve every detail did not diminish the experience. Astronomy often advances not through polished answers, but through the arrival of new questions. As the object crossed the threshold into the outer solar system, observers sensed a gentle detachment. Not one of the loss, but of continuity. The visitor had moved through the heliosphere as countless others have over cosmic time, quietly, briefly leaving behind only the light it reflected and the data it offered. What it did not reveal would remain part of its story carried onward into darkness. And so, the 11th chapter settled into stillness. The object faded from practical reach, its signals waned into noise, and the sky returned to its familiar patterns. Yet something intangible remained, a softened awareness that even brief encounters with ancient matter can reshape how we understand the night. The universe keeps its oldest stories hidden, but now and then it lets us witness a single passing page. What remains tonight is a quiet realization, even after months of watching, measuring and tracing its fading light, we still hold only fragments of what passed behind the sun, and perhaps that is enough. Not every visitor reveals its purpose. Not every anomaly resolves into clarity. Some stories drift through our sky only long enough to remind us how vast the unknown still is. Traveller. The object has slipped into darkness once more, returning to the silence that shaped it. Yet the questions it stirred continue to move with us, questions about age, origin, and the strange intelligence woven into the fabric of the cosmos. What happened behind the sun did not change everything, because it answered anything. It changed everything because it invited us to look closer, to listen more gently, and to accept that mystery is not a barrier to understanding, but a companion to it. As instruments fall quiet and the last observations settle into memory, the sky remains open. Other objects will come, other stories will pass near our star, and somewhere in that unfolding we will learn again how to observe with patience, how to wonder without fear, and how to let the unknown rest without needing to be solved. Rest well beneath the darkening sky. Stay curious, the universe will keep watch.